In this final chapter of our sequence of tutorials, we're going to make a topographic profile for the geologic cross-section. Here we are with our layout. Things are still looking good. Go back to the map where we'll do some work. And so from here, we're going to add data. The important thing is we're going to add an elevation source layer. And so in here, we just need to find our topographic map. So it's inside of the geodatabase. And it's this DSM 1 meter. Even though we have it already added as a base map, we have to specify it as an elevation surface from which the data are pulled for the profile. Appears down there as an elevation surface. Now we can go to the analysis ribbon, and we want to do exploratory 3D analysis elevation profile. So this is pretty straightforward. Let's do distance units meters, and we're going to do this interactive placement where we're going to just draw where we want the profile to be done. I'm going to go right through Welcome Hill, and so I clicked once, and now my snapping's on, so it's going to snap me to the other side. I want to make sure I get through that ridge there where the Troy goes to the Martin, so I'll double click, and I've got it. That's it. You see it looks pretty good, nice and detailed. And we can see Welcome Hill. We see this is Hot Dog. Go across the ramp. There's a little step here. We're going the channel. And then this point here is up by where we transition off the Troy into the Martin. And you can see the little dot on the profile on the map is tracking where I am here. So this is going to be helpful for us as we interpret the geology. So once you've got that, then we need to do a couple things to export. So the first thing is export as a feature. And what this will do is it's going to make the line where the profile is a feature class that we can then show on our map so we know where the cross section is located. So choose a good name because this is what's going to end up in the legend. Say OK, and so there it appears. Now if you go back to the layout, you can see it, and it's nicely located, which is what we require. So the only thing I would do is, so if I scroll down through all the geology, I can get to this 1 point black line. So that looks pretty good. So now we can go back to our map. If you drew it, notice how I drew it left to right, so it's in the right order. If you need to flip it, you can click this reverse direction. I would keep it, left to right as in west to east. The next thing, let's export this as an image, elevation profile PNG. I prefer PNG for the file format. And the last thing is then let's export the data for the topo profile, which is CSV table. Okay, so now we're ready to go into a drawing program like Adobe Illustrator. Okay, so I've opened Illustrator. What I'm going to do is do new, and we'll just use a letter-sized piece of paper. Open the image that we exported. And if you just click on it once and copy and go to our one we just opened, paste, you can see it there. Zoom out just a little bit. So now you want to click there's two kinds of selections, the V, which is entire objects, or A, which is direct select, lets us grab specific parts of the drawing. Let's just do the V select, and if I'm going to grab this lower corner, but I'm going to click the shift, so be very careful about that scale this the same in both vertical and horizontal. Now we can zoom in just a little bit. Again, I'll get the V tool back. So it's not a very pretty diagram, but be very careful about our vertical exaggeration, because you see here is 100 to 300, so in other words 200 meters. And this is conveniently goes from 1010 to 1210, so that's 200 meters. So the vertical distance needs to be the same as the horizontal. So the easiest way to fix this is a little bit inelegant. You get the pen tool and you click once and then hold the shift button down and go here to 300. If you click here, it's also right now it's white, so if I just make it black, so if I click, I see it there. So let's grab it, and I'm going to right-click copy and right-click paste. So I've got two of them. So this next one here, if you click on this symbol here for rotate, I can rotate it if I grab it, but hold the shift button down, so that'll give us then it only rotates like 90 degrees. So go back to the V tool, put this over here, so we know the bottom's at 1010 and the top needs to be at 1210. So now if I click on graphic and I don't hold the shift button down, I can drag this vertically and stretch it. So I've got it. So now if I do Control-0, this brings me back to the main view. So this diagram is now ready. It's a one-to-one topographic profile. So there's no vertical exaggeration, which is a key requirement for us to draw a cross section. If you go over here to the right, you can see there's a layer tool. And so this layer, I'm going to double click. I can call this the original, and you see it's visible. If I click here, I'll lock it, and I'll make a new one, and this can be my drawing. So what this does, this layering lets us not disturb that original drawing, and we can click above it. So now we have to build our topographic profile manually. So I get the pen tool, and I'm just going to click out this topography. This is the inelegant part of this process because there are other ways to bring the topography in. All right, so I've got my topo profile, and if you want to check it, you can go back to the layer control, and if you just turn the bottom one off, you can see, okay, we have the line, but actually there's no color to it, so I need to bring this boundary one up to the front, and I'll just make it black. And maybe I'll make the line weight a little thinner, 0.5, and keep going. So as a reminder, here is the anatomy of the cross-section that we have from our Haddad packet. So I've helped you get the constructed topographic profile. You'll need to add the rest. To do this topo profile, if you have a little bit of programming skill, and remember, we exported the CSV file from Arc Pro. It is comprised of 3 columns: point ID, the distance, and the elevation. So this is really what comprises that topo profile. So you could try to plot this cell, but you can also plot it in other software, and you could do this in Python, but I've done it in MATLAB. I wrote a little script. In the script, we can see it's quite simple. We just need to read the table. That's our profile, our CSV file, and that pulls in data that we just saw: point ID, distance, and elevation. So then the rest of the script opens the figure, clears it, plots distance versus elevation as a black line. The key thing here is does axis equal. So this ensures that the vertical exaggeration is 1-to-1. It labels the axes, turns the grid on, and then prints out the PNG and PDF. So I had originally designed this for just in case somebody wanted to print this out on a piece of paper and draw it. And so here you see the results. So it looks really good. It's very clean, and it's a 1-to-1 plot. So now if we go back to Illustrator, I can open the PDF file that I just produced. And again, I'll do Control-0, select all, Shift, and scale it evenly in both directions. We don't want to deform it. I can get my A tool, and there's a little white polyp thing in behind. So you can clean this up, but the most important thing is if I click on this, you see that topographic profile is now editable, and it's very accurate, so we don't have to click it out. So it's kind of more elegant in my opinion. Many points there that comprise that profile. So you would proceed from here, make this a separate layer, and start drafting, but you could maybe clean this up, delete aspects of the grid that we don't need. Let's get this out of the way so you could make these axes a little bit tidier, and you're ready to go.